So hi guys, welcome to the channel Learning Competitive Programming with CodeChef. So if you want to learn competitive programming and master data structures and algorithm, this is the prime location for you. Every week there will be several videos on various difficult concepts of competitive programming and the editorial videos for CodeChef contest. So if you are new to the channel, then please do subscribe to the channel and turn on the bell notification. So myself, Chirayu Jain, I am from Jaipur Engineering College and Research Center. I am a CodeChef educator. Now the problem that we are going to discuss today is horoscope matrix with the following code, and the prerequisite of the problem is none. Now what will be the agenda today? First of all, we'll discuss the problem statement with the help of examples. Then we'll move towards the approach and understand the approach with the help of examples. And then finally, we'll go through a walkthrough of code in C++. Okay guys, so let us understand the problem statement. All right, so first of all, what has been given in the problem, that there is some Bhavish and who wants to find the horoscopic matrix. So you will be required to find the horoscope matrix. So what will be the condition? That a horoscopic matrix or a horoscope matrix is said to be good if each of its diagonals directed from top left to the bottom right contain equal element, right? So we have taken an example, we have taken a sample input, right? So we have seen this matrix. This is a matrix which is of 2 cross 3, and each of its diagonals must have equal elements, right? So what are the diagonals from top left to bottom right? All the diagonals, right? So we can consider this as a diagonal, only a single element. We can consider these two elements within a diagonal, right? We can consider these two elements within a diagonal, right? This is a diagonal, right? So all the elements must be equal, then only it is a good matrix, right? A horoscope matrix. So all the elements are equal. We can see in the diagonal it contains only one element, that is 7. It contains two elements and both are 1. It contains two elements, both are 4, and it contains one element, that is 3. So all the elements in the diagonal are equal, right? Same value repeated one or more times, right? So it is clarifying that equal elements means the same value which is repeating one or more times. This value may be different for different diagonals, right? So it is not necessary that we have 1 over this particular diagonal. That means that we should have 1 over here also, over here also, and over here also. No, each diagonal must have the same values. We are not relating any of the diagonals, like this particular diagonal must be equal to this or not. Only the diagonal which we are considering must have the same value, right? You are given a horoscope matrix of n rows and m columns, right? For each valid I and j, let's denote the element in the ith row and the jth column by aij. So we're denoting the element as aij for the ith row and jth column. You should process q queries. We have to process the output of q queries, and in each query we have been given x, y, and v, right? So we need to change the value of axy. That means the array at position x and y to v. So whatever be the value, right? So whatever be the value at this position, we have to change this value with v, then determine if the current horoscope matrix is good, and then we need to determine that whether the conditions are fulfilled. All the diagonals respectively have equal elements, right? Then we have to see that this condition is true. Then we'll output that yes, it is a horoscope matrix and it's a good, otherwise it is not, right? So in this particular example, we have seen all the diagonals, right? We have seen how we'll get the input. First is number of test cases, then n cross m, value of n and m are given, and then the matrix, right? So we have been given. Then we need to process q queries here, that we have 3 queries over here. And in the first query, what we are doing, so first of all, let us just remove the stuff and make our matrix clean. And in the first query, what do we have? We need to update the value, that is at position 1, 2. At position 1, 2, we need to make 4. So what is the position? First row and second column, right? So this is the value. It is already 4. It is already 4. So updation will be good, and the matrix will remain same. And since it is a horoscope matrix, so the output will be yes, it is a horoscopic matrix, because all the elements in the respective diagonals have equal elements. Now in the second query, what do we have? We need to update 5 element at position 1, 1 with 5. Now there's a change. We need to update this element with 5. So at first row, first column, 1 will not be there. There it will be 5. correct? So now here it comes 5. Now will the matrix be horoscopic? No, because at this particular diagonal, if we see that it has only 1 and it has 5, so the elements are different, so it will not be a horoscope matrix. It will not be good matrix, right? Now we'll update it at position 2, 2 with 5. So now this element is changed to 5, that is permanent. Now we cannot do anything other than whenever we receive a query of this particular place only, then only we can update it. Now we have the element at 2, 2. So 2, 2 represents second row and second column, this element. So this will also be updated to 5. Now we see that these two elements match, and this is a perfect good matrix for horoscope, right? So these two elements match, these two elements match, these are only single elements, so they already match. So all the elements, all the respective diagonals have equal elements, so the answer will be yes, right? So this is the question, and now let us move towards the approach of this particular problem. Let us understand the approach of this particular problem. So first of all, what we need to do is build the intuition, right? So first of all, we need to satisfy that the matrix is good or not, right? So what we can do is first see that how many elements are there which are not able to get the matrix good. That means which are not making the matrix good. So the first step will be identify those elements, and if there will be any update on that particular element, then we'll see that the matrix will be good or not, right? So first of all, the first thing that will strike our mind is identify those elements which are not making the matrix good. So first thing is step number 1. Step number 1 is count the total elements in all the diagonal which are not matching. So how we'll get that? We'll see that if the particular I, j element matches with the diagonally previous element or not, right? So we'll see that if the particular I, j element matches with diagonally previous element or not. So let us see how. The first row and the first column will do not have the diagonally previous element, right? So we'll start off with the second row and the second columns. We'll move forward for each element right from the second row and the second column. So let us see these elements, right? These 1, 2, 3, 7, these do not have diagonally previous elements. The elements which have diagonally previous elements are the 1 and 4. So we'll check that they are matching or not. So for this particular one, it is matching with the diagonally opposite element, which is this one. So it is matched. For this value 4, this is not matching with the diagonally opposite element. So this value is creating a problem over here. Either it can be 2, it can be 2 as well, but we are concerned about the counts which are making the particular matrix not good. So till now, how many value we have encountered which are not making this matrix as good? Only a single value, which can be any of them, like 2 or 4, but we are concerned with not the value, not the position, we are concerned with the count, right? So only 1, right? So here we have seen what is the step number 1 that we should think of. Now we have gone through this pre-processing stuff, counting the values and all that stuff. Now we are ready with the count of the values which are affecting this matrix, which are not making this matrix good. Now we will see in each of the query, we'll process the queries and we'll see in each of the queries whether we can decrement this count to 0 or not. If we have decremented the count to 0, what that typically means? That typically means that at each diagonal we'll be having the same value respectively to each diagonals, right? So at each diagonal we'll be having the same values, and if the count is decremented to 0, that means we have a good matrix, a good horoscope matrix. If the count is not 0, if there are some values remaining, that means we do not have the good horoscopic matrix, right? So for each of the following queries, we need to process the things and we need to manipulate this count, that whether the count will be decreasing or increasing. So there are the processing for each query is divided into 4 parts, 4 conditions, 4 important conditions which will determine the value of count, that how the count will be affected. Now the condition number 1. So first of all, we'll clean the matrix. Now the condition number 1, whenever we update the value at position x, y, so we'll call it as a new value. The terminology is the diagonally previous value is the value just diagonally previous to it, right? The new value, as we have told, the value which is just updated, and the old value which was earlier on that particular position is said to be the old value. So these are some terminologies, and count we are maintaining it, right? So till now, what is the value of count that we have? That is 1, right? That is 1. Now the first condition is if the new value is equal to the diagonally previous value, right? So let me say that if at position 4, if at position 2, 3, array of 2, 3, I want to update with value 2, right? So what is the 2, 3? That is second row and third column. So I want to update this particular value with 2. So what will be the old value? The old value will be 4 and the new value will be 2. Correct? Now, if the new value is equal to diagonally previous value, what will be the diagonally previous value? That is this value. So if they both are equal and the new value that we have just updated is not equal to old value, the new and the old does not match, that means we have figured out one thing, that the old value was different and the new value is making the diagonal come to equal. Like it is not guaranteed that the whole diagonal will be equal, but it is somehow reducing the count. So what we will do, we'll decrement the count by 1. Why? Because one thing is clear, the diagonally opposite value, the diagonally opposite previous value is matched, and earlier it was not matching because the new value was not equal to the old value and the count was affected somehow. So we'll decrement the count over here, right? So this is an important condition, that is the new value is decrementing the count. So we'll decrement the count by 1. This is the first condition. Similarly, let us see the next case. This is the one case. So in the next case, let me just say that I want to update the value of a of 1, 2 with 4. I want to update the value of the row first and column second with 4, right? So I am just making it 4. So what was the old value? Old value was 2 and the new value is 4. So this condition is holding true. New value is equal to the diagonally next value, and the diagonally next value, this is true, and the new value is also not equal to old value, right? So this is also true, that the new value which we have just found is not equal to old value. That means the update is reducing the count, because earlier these things were not matching and now these things are matching, so it is ultimately reducing the count. So these are two important conditions when the count will be reduced, right? This is the approach that we should take, that when the count will be reduced, these are the important conditions, that we need to match the values accordingly and see that whether the old value was different or not. If it was different, that means the updated value is good because it is reducing the count, so we'll ultimately reduce the count by 1. Now coming to the next conditions. So we have encountered two conditions yet, and now we'll move forward for the next condition. So what is the next condition? What can we think? What can we think is that whether the updated value can also increase the count or not, right? Let us say that earlier the things were matching, but the new updation caused the things that is not to be matched, right? So let us see here that let me just update array of 2, 2 with, let us say, 5. So what is the 2, 2? Second row, second column. So let me just make 1 equals to 5. So the new value is 5 and the old is 1. So the new value is not meeting, this is not equal to diagonally previous value, correct? And also the old value was equal to the previous value, diagonally previous value. That means that it was not incrementing the count, here, but the updation caused to be incrementing the count because it is making the previous value not equal to the updated value. In this particular case, what we will do, we will already increment the count. Why? Because now the updation is not good, it is not making the matrix come near to a good matrix. So ultimately what it is doing, it is just incrementing the count. So we'll increment the count over here. And similarly the fourth condition, that is, if the next value, let us suppose that I am updating this value with something else. So if the diagonally next value caused the same results, and earlier it was matching but now it was not matching, that means the new value is not equal to diagonally next value and the old value was equal to diagonally next value, that means ultimately we'll increase the count. So that depends on queries that you are getting, you'll get. So ultimately, after processing all the things, if the final count is equals to 0, that means what will happen, all the diagonals will have equal elements respectively. So we'll output yes, otherwise we'll output no. So this is the clear cut approach. As the question says, we'll move in that particular direction, but we'll think accordingly that what was the old value, what was the new value, what are the things that we are going to process in queries. So this is the whole approach. Now it's the time to code the approach and see the walkthrough in C++. Also, did you know that CodeChef also conducts free live classes on Unacademy where we teach every possible topic related to competitive programming? We have beginner level courses like Introduction to Programming in C++, Java, Recursion, Basic Data Structures, as well as advanced courses like Dynamic Programming, Graph Theory, and Segment Trees. So these courses are conducted by top coding experts who are ICPC World Finalist, IOI Medalist, and working in product-based companies like Amazon, Google, Facebook, and LinkedIn. So all you need to do is download the Unacademy app or register yourself at unacademy.com and choose your goal as competitive programming. You can also take the Plus paid subscription to get additional features and individual level support. In Plus, we have a large set of practice problems associated with each topic covered. Also, we have 6-star, 7-star rated teaching assistants to clear all your doubts during the live sessions. You can also use my referral code, which is Chirayu Jain, to subscribe for the Plus classes and get an instant 10% off. So hurry up guys, don't miss out this lovely opportunity and kickstart your journey for competitive programming. Okay, so let us see the code walkthrough here. Right, so as we have discussed in the approach, we'll do the same thing over here. First of all, we'll enter the test cases, and for each test case, what we are getting is, we are getting two values, that is n and m, number of rows and columns. So we'll make a matrix for n cross m, that is array. We'll name it as array, and we'll make count equals to 0, in which we are getting the same count that we have discussed in the approach. That is the number of elements which are making a matrix, a horoscope matrix, that is not good, right? So we'll take the count in this particular variable. Now we'll input the values for every I, j element. We'll input the values in the array. And now what we will do, we'll take the count of that element. So how we can do this is, we'll start off with the row second and column second. So ultimately, why we are beginning it with 1? Because the indexing is from 0, right? So the second row and the second column will be represented by 1, 1. So we'll start from this, and we'll see that if the particular I, j element matches or not with the diagonally previous element. So what is the diagonally previous element? That is array of I minus 1, j minus 1. So this is the diagonally previous element. So we'll see the matching. So if it does not match, that means the count is incremented. So we'll increment the count efficiently, right? So this is how we are getting the total number of count. This is how we are getting the count of the elements which are making a matrix not good, right? So this is the overall count. Now for each query, what we will do, we'll get the input of three things, that is x, y, and v. At position x, y, we need to increment with v, but the value that we are getting is on 1 based, right? That is array of 2, 3 at row 2, column 3, but the matrix that we have just inputted is 0 based matrix, right? So the 1, 1 element which we are getting represents the 0, 0 element here. So what we will do, we'll simply decrement the values, right? Because it's a 0 based indexing matrix. Now the old value at position x, y, we'll store it in a variable old, and what we will do, we'll update the value at array x comma y with v that we are just getting over here. So we'll update the value here, right? So we are getting the old value and we are updating the value at array of at position x comma y. Now we'll check those 4 conditions over here. So first thing, we need to check that are we going beyond the boundaries or not. So if x minus 1 is greater than equal to 0, that means that if we are doing the checking the previously diagonal previous value, that whether we are going beyond the boundary, that means we are going below 0 or not. That will not happen, right? Because if we encounter first row and first column, we'll automatically go beyond the 0th row or 0th column, right? So we'll check these conditions. If we are in the boundaries, that means x minus 1 is greater than equal to 0 and y minus 1 is greater than equal to 0, then what we'll do, we'll check the condition that if the diagonally previous value is equals to the new value and the old value is not equals to the new value that we have discussed in the approach. If this happens, so then count minus minus. Similarly, we'll check for the next value, diagonal next value also, and we'll check first the boundary conditions and then we'll decrement the count over here and check the following condition that we have discussed. If the new value is equals to the diagonally next value and the new value is not equal to old value, we'll reduce the count. Similarly, we'll check whether the new value is not equal to the diagonally previous value and the old value was equal to diagonally previous value, then we'll increment the count here. And similarly for the next element, and ultimately after each query what we'll process, we'll see that if the count is 0, then we'll output yes, otherwise we'll output no. So this is the simple code in C++ that we have just seen. We have discussed the approach, we have seen the code, and now it's the time to submit this code on CodeChef. Let's submit this. And we got AC.